So hey everybody, welcome to ARE Live. I'm Mark Tier, the founder of Black Spectacles, and today we're going to be covering project development and documentation, or PDD. That's two Ds with one P.
It drives me crazy that they designed this system to have a PPD and a PDD. Like, it just seems like there was other letters in the world that could have come up with a way to make this less confusing for everybody, but there you go.
Okay, so today we're going to use a mock exam, and we're going to cover a variety of topics in this particular division of the ARE. During this episode, we're going to share the answers to the mock exam and discuss some of the specifics as to why the answer is correct. And then as we go through this review, it's going to help you prepare sort of how to think through the ARE question, so you'll have some practice and gain a little confidence as you think about taking the test. Now, if you go along and if you have questions, I'd encourage you to post them on our ARE community. So if you go to community.blackspectacles.com, you can post any questions that you might have there, and we have folks who are engaged in that community who can answer your question. So I'd encourage you to go to community.blackspectacles.com to post your questions there. In our next ARE Live broadcast, we're going to discuss how to remove diversity obstacles on the path to licensure with a number of people, including Jason Pugh, Midwest Region Vice President of the National Association of Minority Architects. That's on February 27th. We'll drop a link here. Of course, you can also go to our website to register for that. It should be a great session. For those of you who are joining us for the first time, Black Spectacles is the first ever NCARB approved test prep provider for all 6 of the ARE 5.0 divisions. And we have a variety of plan levels and durations to find a membership that best suits your needs. Over the last, I think, 3 weeks maybe, we launched our first online forum, which we're calling the ARE community. And our communities, for those of you who've got questions about the material on the ARE, it's a really great place. We have a lot of folks who've got their eyes on the community and who are providing responses to lots of different questions. It's also a good place to network with other architects. And share your knowledge. So if you're knowledgeable on certain topics, it's a great place to share that and your experience to aid others on their journey to licensure. And one of our favorite features or traditions almost that we've started is at the beginning of the week on Monday, we post a 5-question practice quiz that you can take for free. It's at the top of the community every week. It's a great way to keep your skills sharp and kind of keep you motivated and moving along through your studies. So you can if you're already a Black Spectacles member, you can just go to the community.blackspectacles.com. If not, you create a quick account and then you can go there and you can post questions. So certainly encourage you guys to check that out. And lastly, as I always like to say, if you'd like your boss to pay for your Black Spectacles membership, be sure to tell them about our firm licenses. Whether you work at a 10-person or 10,000-person firm, we have licenses that can work for all different sizes. So go to blackspectacles.com/firm to learn more about that. We also just dropped that link in the chat box. And today we have a special discount on Black Spectacles individual memberships to share, and I'll provide that coupon code at the end of the show, so stay tuned. For our giveaway today, we're doing something a little bit different. Now that we have this community, well, we're going to use it. So normally, well, instead of what we usually do, what we're asking this time around is go to our community page, and that's where you found the mock exam this time around. And so what we'd like you to do is in the comments, post the question that you had the most difficulty with, your answer, and how you arrived at that answer. And what we're going to do is we're going to pick someone randomly from that group of people who post. So go there right now, community.blackspectacles.com. Laura, who's our community manager, she actually just pinned that to the top of the page, so it should be easy to find. And just write in and tell us what you struggled with or what was the hardest one, and and as I said, we'll give a free T-shirt to the person who's randomly selected from that list. Today, now if you don't know our guest, Mr. Mike Newman, he's a senior lecturer at the School of the Art Institute of Chicago. He's also the founder of Shed Studio, and he's our instructor for Black Spectacles online ARE exam prep lectures. Thank you for joining us today, Mike. As always, we'll be taking questions during our live session today using the GoToWebinar question box. And so with that, I'll hand it over to you, Mike.
All right, let's jump right in. as Mark said, we're doing the PDD, the project development documentation, and this is that sort of point along the process, if you will, where you've gone past schematic design, you've gone kind of past the design development, and now you're really talking about that kind of CDs, getting ready for bids and permits and things like that. Kind of you've already made some of your design decisions, and now you're trying to make it sort of detailed and understandable for bidding and all of that purpose. So the kind of tone of the questions ends up being a little more specific and a little less designy for the most part. So let's just jump in and see what we got. Okay, so this first one, the design team is detailing the wall systems for a classroom space. There is a concern regarding acoustic issues. Which of the following wall types will have the highest STC rating? So first thing I want to mention is that STC rating, which is the sound transmission class, is talking about the key thing there on STC is going to be the T, which is the transmission part. So what that's saying is it's all about like sound going from one room to another room, which you could imagine in a kind of classroom setting would be important. You have one class where they're making a bunch of noise doing a project, and you have another class where they're trying to take a test. You're worried about the transmission of sound going through those wall assemblies. And so you would be very nervous about the STC rating. Another sort of issue you would probably be worried about would be the NRC. So NRC, which is another sound issue. In that case, the R, which is the noise reduction coefficient. So the big word here on that one is the reduction. So that one's talking about the sound inside a space, not talking about it transmitting from one space to another, but the sound inside a space. Both of these issues would be important issues in a classroom setting. And the reason that the noise reduction in a classroom setting would be so important is you wouldn't want a really lively sound in a classroom where the sound is bouncing really harshly. Like imagine you made a classroom made out of glass. A lecturer would be talking and the sound would just be echoing through and it'd be garbled for everybody. So you'd want to have surfaces that can absorb and reduce some of that sound. So a huge issue on something like this would be the NRC, but the other big one is the STC, the sound transmission class. And so it's all about sound moving from one side to another. In this case, we're talking about wall assemblies, but it could be through floor assemblies, it could be through doors. You can talk about STC ratings and windows and all sorts of different things. So sound is going to transfer through a bunch of very easy ways. So like if you have a window opening in the wall and you have the window open, well, obviously the sound will go through that. If you have just sort of a poorly constructed wall and there's a lot of gaps between, say, the drywall and the floor, well, that gap is like a window opening and the sound will go right through there. So there's a bunch of sort of simple ways that sound transmits from one side to another. But then there's a bunch of more complicated ways. And one example would be in wall assembly. If you sort of imagine you have a wall and you've got somebody, let's say this is me speaking over here, and so I am speaking and the sounds are going up against that wall, the wall board, the drywall, is going to reverberate from those, it's going to have vibrations from those sound waves. And that reverberation in that wall board is going to make the studs reverberate, and then that's going to make the wallboard on the other side vibrate, and then that's going to send sound across on the other side. So it's this weird level of transmission that's beyond just the fact that there's holes in the walls or anything like that. It's actually this sort of combination of sound waves and vibrations that will send sound waves through. And so there's a couple different things that you want to think about from a sound transmission standpoint. One is, can I stop some of that vibration? The other is, if I use sort of dense materials in specific ways, can I deaden some of the sort of process of the transmission of that? And so there's a couple different ways you can start to think about those things and how you start combining them together. One important thing to realize is that sound is really tricky, A, and B, you will never win the game of sound unless you are spending, enormous amounts of money and have highly paid specialists coming in because you're doing a symphony hall or something like that. There is always going to be sound from classroom A to classroom B. You're just not going to be able to stop it all without spending an enormous fortune. The trick is you're looking, and this is what the STC is all about, is you're looking to stop the most annoying sound, which, if you think about it, like, what's the most annoying sound? What does that mean? Well, you might think it's really high sounds or really low sounds. It's actually the sound where human voice is. What you're trying to do is you're trying to deaden as much of the sound of the human voice, making it from one room to the other, because that's the one that's going to catch people's imagination. Like, if you're sitting in one classroom and you can hear the lecture in the classroom next door, it's really hard not to just listen to it. So the STC, all about transmission of sound. In many ways, you'll see that it's really about sort of the keeping the vibrating materials separated from each other as much as possible. So let's take a quick look at these different wall types. The first one is a very straightforward. There's a metal stud at 16 inches. There's a drywall on each side, 5/8 inch drywall, but there's also a 1/2 inch resilient channel. So what's a resilient channel? A resilient channel is a small sort of metal, kind of like a small stud, if you will, a small metal stud that goes horizontally across from stud to stud. And it essentially becomes a little spring. And the idea is that as that reverberation happens on the gyp board, as on the wall board, it reverberates, and that little bit of resilient channel can sort of absorb some of that vibration, so it doesn't pass as much vibration through to the studs and then to the wallboard on the other side, so it can slow that process. So that's a good thing from a sound transmission standpoint. So from resilient channel, that's much better than just wallboard on the side of studs. Wall type B, we've got no resilient channel, but now we have double studs, double wallboard on both sides. So we have 2 layers of 5/8 on both sides, which is going to be a denser material on the outside. That's a good thing, having the dense material on the outside of the cavity. That's going to help. So that's actually, those two are pretty close, but the second one, B, is actually a little bit better. But when we really start moving along, we get into the ones where we're doing 2 separate stud lines as one wall assembly. And the obvious reason for this is that there's a huge advantage. If I can separate those 2 studs, it makes it harder for that vibration to kind of go from the wallboard into the stud. It has to then make a leap across to the other stud before it can get to the far wallboard. So it's a big advantage in terms of slowing down that vibration. Now, an important thing to remember is the floor is still going through from one side to the other. So it's not like you're, cheating the system here. The sound will figure out other ways to get there, but it will help. So both of these last 2 are going to be better than either of the first 2. And then here comes the weird thing. The actual answer here is type C, which doesn't make any sense at all. That's where I've got 1 layer on the outside of each side. And you would think with the other one, which has more layers of drywall, that would be better, that D would be better. But in fact, those little layers create a situation where it allow the sound waves to find material to vibrate with, and keeps the vibration moving through. It also reduces the space. The bigger cavity allows for a sort of capturing, if you will, a bigger sound wave. So weirdly, C is the correct answer. However, for those of you who are sort of fighting at home for getting this right, I'm actually going to accept D as well for the moment. I was doing a little research over the weekend, or excuse me, this morning, and I found a couple of resources, USG and another one, that used different ways of thinking about how the materials were assembled, and their numbers, their STC ratings were much, much closer than the other one that I'd originally been using, which is stcrating.com. So it's a little bit more confusing depending on who you're looking at. So we'll accept D as well as a reasonable answer, but the sort of true answer here is wall type C. So that was a lot of information about sound transmitting, but
yeah, that's right.
You
guys got a full
hopefully
dose
you get
there.
the idea there.
Yeah, if you guys struggle with that question, love to get any feedback or any any thoughts.
And it's not
in the community.
Yeah, absolutely. That'd be a great place to feedback to. It's not that STC ratings are the most important thing in the world. It's just that it's a easy kind of question to be able to be asked, and it's a useful thing. It's an important thing to clients. So it's just one of those things that shows up a lot. That kind of issue shows up a lot on the exam, and you should absolutely. There's lots of resources out there. USGs. Lots of other manufacturers have very good online resources to just sort of go through. You don't have to memorize all the STC ratings or anything like that, but you should have a sense of how they work and the impact of one choice over another.
One other thing I'm noticing, a lot of people are asking a lot of questions here. It might not be a bad idea to throw some of them into the community, and we probably won't be able to catch all of them. So maybe we could try throwing some of them in there, and then we can kind of tackle them as we go along.
Sounds good.
Cool.
Okay, so move along.
Yeah, please.
Number two, there's concern that bids will be over budget. You, the architect, should probably consider using what tactics in the bid package. You could choose 3. So there's a couple ones in here that are definitely not true. So I'll just call a few out. One is F, using AIA form G704, suspend the project until the owner has appropriate finances. Really, that's just not your call. You don't get to say to the owner, project is suspended. So that's not something that's reasonable. And also G704 is about substantial completion. So it's just sort of wrong from multiple standpoints. So I'm going to say no to F. And then the other one, submit the RFI, and this is C, submit the RFI to the funder and the banker. You don't really, that's not the terminology that you would do. You wouldn't even really ask a banker questions. You would ask the owner questions, who would then ask the banker. So it's just not a reasonable answer. So the other 4 are all sort of reasonable answers. And then the question is, which are the 3 best of them? And one is include add alternates. So what that's talking about is for the bid package. So you're at the end of the CD phase, you're put together your construction documents, your contract documents, and you are getting material ready to go for permit and also for bidding. So you're putting together the bid package, and what the add alternates is talking about is you're worried that you're going to be going over budget. So you, in the bid package, you essentially say, all right, here's the baseline of what we absolutely need to build, but then we also might be able to build this other thing that's included in the drawings. Let's say the built-in furniture or special cool ceiling system or something like that. And then you could put those in as add alternates. And then when you get the numbers back from all of your bidders, you'll get the base number and then a number for each of the add alternates. And it becomes a way that you and the owner can sit down and go through and say, all right, the numbers did come in high. I guess we can't do any of those special things. We'll just have to go with the base. Or, yeah, hey, our numbers worked out. We can get most of the ads that we wanted. And so it's a way of sort of controlling the flow of information so that you're not just at the whimsy of what information the bidders want to send to you. You're actually controlling that so you get really apples to apples and useful information that you can compare from one bidder to another, but in that context of worrying about going over. A similar one is going to be request the unit cost information for specific materials. This is actually seems a little odd. It seems sort of weirdly specific, but this is one of those things when you're worried about cost overruns on the bid process. This is one of those simple ways. You have to be a little careful not to overdo it. But for example, let's say you're doing a school or something and you want to do a terrazzo floor. Well, terrazzo floors are fantastic and they'll last forever, and they're really durable and great for that kind of thing. It's like, it would be an awesome thing to do, but they're also expensive. So you might say, all right, our baseline is going to be a terrazzo floor, but also give us a square foot number for vinyl tile or something, right? Or maybe you do it the other way. Maybe our baseline is vinyl tile, but then give us a square foot number for the other. So that way, when the information comes in, you can say, all right, well, here's the project, but really we can't afford the terrazzo floor, but you don't have to then rebid the entire project out in order to get the new number. You now have, you've asked the bidders to give you enough information that you can swap pieces of information in and out to sort of fine tune that bid. It's a great way to do it. If you ask for too many things, then the bidders are going to start being a little skeptical about the whole process, and they're going to not want to answer anything. So if you have a list of, please provide us with these 100 different materials, that's too many. If you have, 5 or 10 or something like that that are really meaningful, it could be linear feet of a certain kind of wall type. It could be square footage of a certain material, like one roofing material versus another. Any number of different unit systems for thinking about those things. It's a great way to be able to control the bid package, how much money you can negotiate. So then we're down to A and E, and I think both of them are plausible. I would definitely go for E, which is review bidder qualifications to ensure the inclusion of bidders with experience at cost efficiency. You have to remember that the bid package and that whole process is actually, there's a whole process about bid qualifications. You're going to get quite a wide range of bidders. You may want bidders that don't have a lot of experience with efficiency because maybe they bring something else. Maybe they bring certain kinds of connections to the city, or maybe they bring a sort of fast-paced or they're easy to work with or something like that. But if you're worried about cost, you would want to make sure there's somebody in there who's well known for making those costs work. So important roles for the architect at that bid package collection information moment. And it's always important to remember that the bid package, the bid letter, the thing, you're not just sending drawings out, you're designing the system about how the information is going to come back in order to make it the most useful as possible for you and the owner to be able to discuss through. Okay. All right, number 3, this is sort of a little bit of a detail one, but I put this in here because I just want to encourage people to look at some of the base information about the materials, because you'll find that it's an easy source of questions, and it's a good way to sort of think about, and the reason it's an easy source of questions is because it touches on materials and systems, but also on people and durability and sustainability. And so it's a sort of easy way to kind of talk about multiple issues in one simple question. So in this question, which of the following cuts from the same log would produce flooring with the best wearing characteristics? So in other words, be the most durable. They would wear the best. It wouldn't wear down easily. And our 4 choices are quarter sawn, plain sawn, rotary sawn, and half round sawn. Rotary sawn and half round sawn are both kind of interesting possibilities, but those are neither really reasonable in this context. The real question is really plain sawn versus quarter sawn, and I'm not going to go into a long thing about it, but a real quick version of these two is if you're doing quarter sawn, you divide it into quarters, hence quarter sawn. And then you're cutting out all those different pieces of wood, and you do that out of each of the quarters. And then plain sawn, I'm just going through and cutting it up, so I get lots of different pieces. It's much simpler, it's much easier, it's much faster. So plain sawn is the cheaper way to go. Quarter sawn is much more expensive and wastes a little bit. But the big advantage of quarter sawn, which is going to be the correct answer here, the big advantage of quarter sawn is if I choose any one of those pieces and we sort of look at it up close, when you think about how the rings are working as it goes through, the rings are all going to be roughly equal to each other as you look at the cross section of that wood. So if I looked at the grain pattern on the wood, it's going to be essentially straight lines coming down. And those straight lines, the darker parts are the hard parts of the wood, the lighter parts are the softer parts of the wood. And because it's nice and even, you're going to get a really even wearing, and it's going to be much, much stronger. And so if the issue is the wearing characteristics, then quarter-sawn is absolutely the answer. There are going to be plenty of times, though, where the grain look, it'll have what's called cathedraling. This is in the plain sawn. So you'll see that kind of grain look. And there's plenty of people who love that kind of high grain, kind of high, very character-filled look. And so if the question was about that, well, then the plain sawn might be the right answer. In this case, the question is about durability. And I use this question again, it's a kind of a detailed piece, but the idea is to sort of say, you know, just have a feel for different materials. We could have similar conversations about aluminum versus steel in certain situations, and one rusts and one corrodes in a different way. And like just sort of understanding those materials and sort of having opinions about where you would use one and not use one, that kind of thing.
Getting some interesting comments on the community here. One thing that's making me think of is one of the things we've learned over here is that a great way to reinforce your learning and sort of your own thinking and knowledge is actually to like write it out, you know, so like
Absolutely.
Take notes, and it helps you kind of like, it helps, you know, reinforce the thinking that's going on in your brain. So I appreciate the folks who've already posted and would encourage the rest of you to do so, especially on this one about the wood flooring. That's a good one.
Yeah, and you know, the key on those things, writing it out. The other thing that I found was really useful for me was I would find photographs, you know, like go through books or something, and or you know on websites and find an interesting photograph. But then the key part is you don't just look at the photograph. You actually draw on top of the photograph.
Oh, that's a good idea.
And you sort of say, all right, so here's the cut, where's the grain, and you draw the grain in, and suddenly the photograph. Like the problem with photographs is that they look sort of interesting and beautiful, and it just sort of wash over you, and all right, yeah, that's cool. Look, it's a photo of some wood, you know, like great. But when you start drawing on top of it, you suddenly start analyzing it, and it stays in your brain much more clearly. It's a great, simple way of doing it. So I highly recommend that. But yeah, those kinds of little tricks of getting out of just letting it be passive and making it more active, you're much more likely to really think of it in an analysis sort of way.
Yeah, actually, that might be a good provocation here. It'd be great if someone could post, you know, maybe grab an image or something from Google for that quarter sawn. Be cool to see that and post it in the community for everyone to see.
Yeah, and the other ones that I sort of dismissed sort of quickly, the rotary sawn and other things, those have other uses, right? You're making plywoods, and you're making, you know, all sorts of other things, and you suddenly you start understanding, well, why you alternate the ply directions and things like that once you start seeing the physicality of the log as part of that process.
Yeah, Edward posted, he asked the question here. I said, what about rift sawn? I don't know, Edward. Let's see it.
Yeah, rift sawn would be another possibility. I would still go with the quarter sawn, but yeah, it's another good one to look up. Okay, I'm going to move on. Number 4, what might I find in the air gap of a brick veneer wall? So this is kind of an odd question, just the way it's written here, but I can guarantee you there's going to be a question kind of like this. Because this is such a sort of key sort of thought about like how do we, if you have a brick veneer wall, so that means there's one width of brick on the outside, there's an air gap, and then there's a backup structure. That backup structure could be CMU, it could be metal stud, it could be wood stud, but the structure is a separate element with this air gap in between. So let's see here. We could sort of easily imagine, what should we do? How about a CMU backup? So I'm just going to draw this out a little bit here. So there's our foundation wall. It's got some rebar in it somewhere. We've got a slab here. We've got little fibrous fillers there. We've got the CMU Backup. And then out here, I've got a bunch of bricks, which are hopefully built better than I'm drawing.
Yeah,
them.
those are something. My kid's Legos look better than that.
That is a terrible, terrible brick wall. So somebody's getting fired from that process. So I've got this white, this veneer, that's this outside layer. You remember that if you're using sort of regular bricks, there's lots of different brick types, but probably about 60% of the bricks out there are going to be sort of these regular size bricks. I'm being careful about not saying standard, because standard is actually a particular size of brick. But these sort of regular bricks, you're going to have 3 bricks will add up to 8 inches, and therefore there'll be the ability to have ties that go straight across at those every, say, 16 inches or every 24 inches, depending on what you're doing. So the size of the bricks is aligned. And then we have this great big space here. And there's going to be various things that we're going to be able to sort of put in here. One is the metal ties, which I just drew in there. So we know that A is a correct answer. That's in the air gap space, which is right there. The other thing that's going to be in there most likely is going to be insulation. I'm going to have some rigid insulation right there. And that rigid insulation is going to be sized so that it fits between the ties. I'm then going to have probably a house wrap, an air barrier kind of thing. So that'll be layered on. I'm going to have some flashing that's going to come down. There's a lot of different ways I might do that, but there'll be some what's referred to as through wall flashing. And the whole point of this whole process here is that any water, if you imagine you get rain and all that stuff, it's soaking up this outside face of the brick. And the brick is relatively porous. And so that moisture is soaking all the way through. And if you had a solid wall, then potentially it can soak all the way to the inside and start damaging elements on the inside. But because you have this air gap, the water will collect on the air gap side of that brick veneer, and then it'll eventually drip down to the bottom, and then the flashing will force it to the outside, because we're going to leave some weep holes down at the bottom, some holes that allow that water to get out. So that's the whole point of what's going on. You should be able to draw this in your sleep, because there's going to be a question, and maybe it's a drag and drop or something like that, where you'll be asked to put the ties in, or to put the flashing in, or at a lintel, you know, where the flashing would go at a lintel, something. This kind of wall system is bound to show up. So I just wanted to make sure that we had a chance to say, you know, feel comfortable with it. Lots of other wall systems too, but definitely this one. So we've got a couple of answers here. Next one I'm going to say is the rigid insulation. So that was that right there. And then the flashing were the 3. So the word wythe is a useful word. What that's referring to is one line of masonry. So the veneer, that veneer line right there is one wythe of brick. And that CMU line right there is one wythe of CMU concrete masonry unit. Efflorescence is when the brick, that once it gets soaked, and then the air starts to evaporate the moisture back out. Well, when the moisture got into that brick, it absorbed all of the salts that are naturally in the clay. And then when it evaporates away, it leaves the salts on the surface, salts and other minerals. And so you get that white, dusty stuff on the surface. That's efflorescence, but doesn't apply in this question. And you wouldn't use blown in cellulose in the cavity, because then you'd lose the cavity. You need the air gap in order to allow that space for the water to flow down. So that's why the other three, even though they're plausible in many ways to be part of the wall section, they're not part of this answer of this question. All right. Number 5, finalizing the window schedule the Skylight Glass should be. This, when you talk about glass, there are lots and lots of different choices. There's all sorts of different add-ons. There's a whole big wide range of possibilities. However, given the 4 choices we have, there's really only one way you could answer this, and that the Skylight Glass is going to want to be laminated. Okay, so why? So first of all, laminated glass is when I have many layers of glass. So I'm zoomed way in, and in between each layer, I've got a little bit of like a plastic sheet, if you will, a sticky on 2 sides plastic sheet that kind of glues the glass together. And so the overall might be, say, a 1/4 inch thick or something like that, but it might be made out of, say, 3 layers of glass with 2 layers of plastic in the in-between spaces, or more layers, depending on how important the situation is or how durable you need it. And the reason that we want to use the laminated glass in a skylight, remember this is a very specific question, it's about a skylight, is because if something happens, let's say somebody's playing baseball next door and the ball goes up on the roof and smash, it breaks the skylight. The last thing you want is big shards of glass falling down from a 20-foot ceiling onto the floor below where people are sitting unsuspecting. So you want it to sort of hold together as much as possible. One of the reasons that those layers of plastic, clear plastic, but plastic in between, one of the reasons those are there is the glass may break, but it'll hold it up so that you have time to get people clear and safe before somebody can come in and take all the broken glass away and replace it. So skylights are almost always going to be laminated. I can't even think of a situation where it wouldn't be laminated. Maybe there's situations where it wouldn't be, but I can't think of one. One other thing to note, so kind of annealed glass and float glass are essentially pretty standard glass. It's just sort of 2 different ways of making glass. The tempered glass is another interesting one. You've all seen the tempered before. It's made in a really interesting way where they make it very hot and then they cool it down very, very fast. And in the process of that very fast cooling, it puts all these weird forces into the glass. You can't really see it, but the glass has these like forces deep in it, which makes the glass very strong, but very brittle. And the brilliant thing about tempered glass is if it breaks, those forces get unleashed. And so instead of getting a 18-inch shard of glass that's gonna pierce through your sternum, you're gonna get a million little tiny pieces of glass like car glass, which is essentially tempered. Often glass will be both tempered and also laminated, but the key thing on this question is the laminated. So let's say a glass in a glass door, right? That's going to be tempered because if somebody slams the door and breaks the glass, you don't want them cutting everybody up as well. You want it to just sort of fall apart into little shards, little tiny, tiny shards, so that it can't hurt anybody too badly. So both are interesting ones. In this case, Skylight's laminated glass. All right.
I'm having a hard time keeping up with everyone on the community now. This is kind of interesting. A lot of interesting questions here. Let me see if I can pull anything out of here. I guess interesting one here. Z Peterson says, so tempered glass for vertical applications and laminated for horizontal? It's not that simple, right?
No, it's not that simple. In fact, often the laminated is more of an idea. Like you can actually laminate with lots of different kinds of glass, and often laminations are actually with tempered glass, but not always. So the point is any place where people are going to get close and it might break, so doors, windows that are in stairwells, so like you imagine you're walking down a stair and you trip on a step, which seems like kind of a ridiculous thing, like who trips on a step, but actually happens all the time. So much of the time that the codes actually say if you have a window in a stairwell or at the bottom of a stair, it's so likely that somebody might trip and fall and like go head first into the glass that window has to be made out of tempered glass, so that if they do and it breaks, it's going to break into a lot of small pieces and not be super dangerous, big, giant shards. But another window that's, say, 6 feet away, but not in a place where somebody's likely to bump into it, wouldn't necessarily have to be made out of tempered glass. So it's more about location and proximity to people. Another one would be glass that's low. Like any glass that's, say, 6 inches off the floor, 12 inches off the floor, something like that. And the reason for that is because, you know, your boots are likely to kick something down that low. It's hard to imagine that it's going to be easy to break something at, say, 5 feet up in the air. So down low, you're going to be required to use tempered glass, things like that. So it's about the relationship to people more than it is about other specific questions. I'm sure it's more complicated than that too, but that's a good
I
way
was
of
going to
thinking.
say, I remember using laminated glass to reduce sound.
Yeah, and laminated glass also reduces sound. It's the plastic helps reduce that vibration moving through, and it's a big factor.
See how I did that? Combined questions.
Yeah,
See?
how about that? 1 in 5, very good. I'm impressed. Okay, so here's we got a little bonus round here. This is some fast questions. This is not these next couple are not questions you're going to get on the exam, because these are simple, straightforward questions. But we just wanted to throw these in here as a way to sort of say, hey, don't forget, there's other stuff you should know in order to answer the more complicated questions. So number 6, bonus question number 6, what is the actual dimension of a typical CMU block? So the block is 8 by 8 by 16, which means that the actual dimension is 7 5/8 by 7 5/8 by 15 5/8. So that other 3/8 is there to make space for the bed joint. This would be the actual dimension, and this would be the nominal. Nominal dimension, meaning it's the named dimension, so what we call it. So it's the nominal and the actual. They are not above switching back and forth between those terms, just to make sure you understand that that subtle difference in meaning. Plus, if you're ever out talking to a contractor, it's embarrassing if you don't know how big a CMU is. So it's the kind of thing you should know. All right, let's move on to the next bonus one. What is the nominal dimension of an 8-foot 2x6? Note the trick here. It says nominal, not actual. So I'm trying to trick you on that one. So the nominal dimension of an 8-foot 2x6 would be 8 foot. There you go. I'm not even sure I would use the multiply there. I just say 8 foot 2x6. That is the nominal. It's the named dimension of that. The actual dimension would be 8 foot by 1.5 by 5.5. One little thing you might notice is that when I put 2 by 6, I did not put the little hash marks, meaning inch, because the 2 and the 6 are not actual inches. It's not an actual dimension, it's a name. So the 2 by 6 doesn't have the inch marks, but the 1.5 by 5.5 does have the inch marks, because that's an actual dimension. So the actual and the nominal. Note that the 8 foot stays the same on both, because it's an actual cut of the full length.
That's such a good example of like I guess the tactics that the question writers may use, and how as you read the question, like you actually, like when I read that, like I read that so fast, I skip right over the word nominal. I go straight to 2 by 6.
Yeah,
I'm like, there's a question that says
1.5 by 5.
what is, yeah, exactly. Haha, I know what they're trying to do, and I skip the word nominal. It's a good example of like, just, you don't have to like freak out about it, but just like, just carefully make sure you read every word.
Yeah,
like,
and
I
just,
would not,
and take quick notes on your scratch paper or something like that if it's a more complicated, longer question, and make sure you go back to those moments. Again, you won't get a direct question exactly like this. It's just more that it might be buried in a more complicated question.
True.
Okay.
That's very true.
Let's see here. Number 8, board feet. Okay, this is one of those weird ones. Back in the day, back when I took this exam, everybody had a question about board feet. I don't know if they do it anymore. I don't know if it shows up anymore. So I just sort of put this one out there just like so people have heard of it in case it still is on the exam. Board feet is something you use if you're ordering, like, okay, we're going to order all the wood for a new house that's going to be built. So we're going to order like a train car of wood. And so you're going to pay for it by board feet. It's like a system for understanding a large quantity of wood. So 1 board foot, if you will imagine, is 12 by 12 by 1. So 1 inch thick, 12 by 12. So 1 foot by 1 foot by 1 inch thick, nominal. So it's a sort of conceptual 1 foot square, 1 inch thick. So in this case, if I have 2 by 4s measuring 24 feet of 2 by 4s, you're going to have to sort of take my word for it. Otherwise, it'll take a long time for me to go through, but I'll do a quick sketch of it. What I'm conceptually going to do, just so I can easily picture it in my head, is I'm going to cut that 24 2 by 4 into 3. I'm going to make it 8 feet long. So this is now 8 feet, and this is now 2 inches, and this is total of 12 inches, nominal. And the reason I do that is then it's 12 wide, it's 8 long, so that I have a 1 foot wide. It's therefore 8 board feet, but it's 2 inches thick, so therefore it's 16 board feet. Again, I don't know if they're going to ask this question. It was always asked. I guess architects used to buy the wood a lot. I don't know what that was about, but I've never heard anybody in the field, I've never heard any architect use the word board feet in probably the last 15, 20 years. So I don't know if they'll ask that question, but there you go. If it comes up, you now know what board feet is. The last one here, special bonus question. A square of roofing has a footprint of 100 square feet. So that's how you order roofing materials. So if you have a 1,000 square foot roof, you need 10 squares. So next time you're talking to a roofer, you can sound like you're knowledgeable and kind of, be the cool guy on the roof who knows what he's talking about.
I was gonna say, I've been trying to like come up with some joke or something, but I can't come up with anything other than just to say you're, make fun of you being old or something.
That's right.
I don't know what else to say.
Yeah, I don't know. Like, it's one of those weird things. Like, if you look at any of the old guidebooks, they'll all have board feet all over the place. And I definitely got questions about it. And like I say, I literally have not heard an architect use the term board feet in 15, 20 years, something like that. So,
well, here we are. We did it. Cool. All right. Well, thanks, Mike. I thought that was really good. Actually, a lot of fun to see all the posts on the community. That's been a lot of fun to kind of go back and forth with folks, as well as here on GoToWebinar. So thank you, Mike. Thanks for everyone who tuned in. If you did not get your question answered here live, definitely hop over to the community where we're standing by and responding to lots of different folks' questions.
And somebody may have responded already even to some of those questions.
Yeah, it's true. It's true. It was probably me.
Yeah.
So our next ARE live broadcast, we're going to discuss the topic of how to remove diversity obstacles from the pursuit of licensure. I just posted a link to register in the chat box. So go to GoToWebinar and hop in the chat box, or you can just go to blackspectacles.com/podcast to sign up. To learn more about our ARE exam prep curriculum, you can go to blackspectacles.com, where you can try out any of our videos. And if you want your boss to pay for your membership, be sure to visit blackspectacles.com/firms to learn more about our firm memberships for firms of any size.
And who doesn't want their boss to pay for it?
Yeah, that's my
I mean,
favorite.
it's such a
thing.
good idea.
Yeah, I'm a boss and they make me pay for stuff. For those of you who are ready to start preparing for the ARE right now, use coupon code PPD013020YT to get a 15% discount for the entire duration of your ARE exam prep membership. Now, we're going to do a giveaway here for a free t-shirt for all the folks who posted on our community. And so I'm going to ask, hey Siri, I need a random number between 1 and 17.
A random number between 1 and 17 is 15.
All right, 15 it is. So Scott, you posted, I don't know your last name, Scott, but you did post on our community, and we're very thankful for that. So we will be reaching out, and we will get your information and send you a free t-shirt. So thank you very much, and thanks for all of you who posted there as well. And then finally, tomorrow we'll email everyone a follow-up about today's live broadcast. So please let us know what you think and share any suggestions that you may have. We read every word that you guys write and to use them to tune our next episodes. So thanks for tuning in.